The concept of work told us that in order for objects to be displaced, force is required. This is actually energy in context. In this session, you will be able to define, classify, and cite examples of energy exertion, relate work, energy, and power, and solve problems involving work, energy, and power. Energy is the capacity to do work. Like work, energy is expressed in joules. There are two classifications of energy: potential energy and kinetic energy. Potential energy is the energy possessed by a body due to its position, elongation, or compression. Energy due to position is called gravitational potential energy, and the potential energy of a body when stretched or compressed is called elastic potential energy. Maybe you are wondering how come there's energy in objects staying still. For example, a rock suspended on a cliff, or a stretched spring. This is due to the fact that these objects are in suspension, and due to this suspension, energy is stored, and this energy is called potential energy. What happens if an energy moved a boulder? What would happen to its motion? That's right, the boulder will roll down the cliff. How about if the spring was set free from suspension? Will it stay stretched? No, it will restore its original form and shape. That's why potential energy is called stored energy. Let's have another example. Gasoline is a flame hazard. Does it contain energy? Yes, of course, it does. It has chemical potential energy. That is why when a spark or a flame was drawn near to it, this potential energy will be converted into kinetic energy, thus allowing the gasoline to combust. Based on this situation, what is kinetic energy? Kinetic energy is set apart from potential energy in a way that kinetic energy is energy in motion, or what we normally observe in objects at work. Work, then, is equal to energy. These concepts are also defined in terms of equations, which describes energy in a quantitative manner. Work, as you may have recalled, is equal to force multiplied with displacement. For energy, we have two main formula. For potential energy, it is the product of mass, acceleration due to gravity, and height. With the concept of potential energy, since objects are held in place by the gravity of the Earth, the G is equal to 9.8 meters per second square, which is a constant value. Let's take an example. The boulder is held in place by pebbles in a 15-meter cliff. You estimated that it is about 1,000 kilograms. What is the potential energy held by the boulder? Remember the formula? First, identify the given. We have the mass, height, and the constant value for G is 9.8 meters per second square. Put all of these values in place for the formula and you will get this answer. We also have the second formula for energy, and this one is set for kinetic energy, which is the product of mass and the squared velocity over 2. This formula is also similar to the following figures. Let's take some example. The 1,000 kilogram boulder rolled down a cliff at an instant of time. Its velocity is equal to 10 meters per second. What is its kinetic energy? Again, we have to identify the given, which are 10 meters per second and 1,000 kilograms. Then, substitute these values into the equation. Take the calculation and we will get this answer. Another concept related to work and energy is called power. Power is the rate of doing work. Power can be expressed in various formula. Therefore, since we only divide work or energy with time, the unit for power is joules per second, or, in this case, power is equal to watts. Let's take an example. The work it took for a woman to bring an item to the counter is 900 newtons. If it took her 5 seconds to do the activity, how much power did she expended? Let's just divide work and time and we will get this answer. Let's take another one. A kilogram ball was rolled 5 meters per second on the floor for 5 seconds. How much power was exerted? Let us analyze this problem and use the appropriate formula. In this case, we first need to take the kinetic energy of the ball, divided by the time of the activity. And we will get this answer. And for our last example, a light bulb usually has a wattage label. For example, a 10-watt bulb uses 10 joules of electrical energy every second. How much energy is consumed if it was run for 3,600 seconds or an hour? And this will give us this answer. This is work, energy, and power in context. In this session, you learned about the definition, classification, and examples of energy, the relationship of work, energy, and power, and solving problems involving work, energy, and power. Thanks for watching and see you again next time.